Welcome, geometry students, to class today. In this video, we will be studying 4 theorems that deal with segments being drawn and proportionality. In other words, we're going to study some theorems in which some segments are drawn, and these segments then divide up other segments or sides into proportions. Okay, so we're going to be looking at 4 theorems today that deal with those types of situations. Now, your heading for today is proportions in similar triangles. Proportions in similar triangles, lesson 8.6, and be sure and include today's date so that your notes are organized. Okay, so take a second, copy that down, and then we're going to continue on. Okay, proportions in similar triangles, lesson 8.6, and then be sure to include today's date. Now, let's start off right away with our first theorem of the day. You're responsible for this theorem, and I want you to copy it in your notes. Okay, here it is. Go ahead and copy this down. I will read it, then I will pause a minute while you copy it down. Theorem 8.4 is called the triangle proportionality theorem. Okay, the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Okay, and this should be proportionally. Make that an L and then a Y. Sorry about that, students. And there we go. Okay. If a line parallel to one side of the triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Now let me give you a picture of this that you really need to see. Okay, here it is. Please copy this down. I want to draw a triangle like this. Take some really good notes on this, please, students. And then draw a line here that's parallel to the 3rd side, and we're going to call this A, B, C, D, E. So put an A here, a B here, a C here, then a D, and then an E. Okay, and we're going to go ahead and state that this is parallel to this line here. Okay, so please watch carefully. Over here, I want you to write down if DE is parallel to AC, then I have the following proportions. Okay, here they are. Please watch this. Now, I can put this side here, DB, over this side here, AD, and say that that equals BE, this side here, over EC. Now, take really good notes, write that down, see if that makes sense. Okay, if you have a triangle and there's a line drawn that's parallel to the 3rd side, and that line also intersects the other 2 sides, then I have these proportions here. This segment here over this segment here equals this segment here over this segment here. But there's also another way to write your proportions. This one here is totally fine, but you could also write this. You could say this segment here changes to this segment here. Okay, so DB over BE equals this segment here changing to this segment here. So AD equals, or AD over EC. Okay, now, either one of those 2 are fine. Please look this over and memorize it for the 3rd or 4th time. One more time, here we go. If you have a triangle and you have a line drawn inside the triangle that's parallel to one of the sides and it intersects the other 2 sides, then it's going to divide the triangle up into, it's going to divide the 2 sides up into proportional parts. Okay, you can say this side over this side equals this over this, or you can say this segment here over this segment here equals this segment here over this segment here. It really doesn't matter. Okay, I'm going to move on, so if I'm going too fast, just tell the teacher to pause the video, and then we'll continue, and then you can continue on. Okay, alright, now let's look at why this theorem is true, and I'm really not going to do a proof. Okay, you are not responsible for this explanation. so I will be quick, but please listen well. If you want to take notes, great. If you don't, I understand, but please listen to this explanation. I think it's really important that you see this, okay? Since I've already got a triangle drawn back here, I'm going to go ahead and use, let's see, where was I? Here we go. I'm going to go ahead and use this triangle for my explanation here. And students, before I get in this explanation, I want to say to you, I feel like it's really important that we explain as many theorems as possible, okay? Because really, when you look at this, some theorems you can look at and say, yeah, that makes sense. Other ones, in my opinion, like this one, are not so cut and dried. So let's really pay attention. I'm going to go fast. Just sit back and listen, okay? All right, here's my little triangle right here. D, B, E. Here's my big triangle right here. I'm not trying to be neat. I'm going fast. B, A, C. Now, we know this angle here is congruent to this angle here because two parallel lines cut by a transversal. Corresponding angles are congruent. We know this angle here is congruent to this angle here. So we definitely have similar triangles, okay? So this little triangle here is similar to this triangle here, okay? So with that in mind, we definitely know that we can state that BD right here, BD, now watch this carefully, BD over BA equals BE over BC. Okay, now hopefully you're seeing that, okay? If not, it's okay, but try to understand this. So I just stated this side here over this side here is congruent to this side here over this side here. Now I can state that because the two triangles are similar, okay? Now, what about this? What is BA? Well, Mr. Arrow, it's the side of a triangle. I know that, but what else is BA? It's this whole side here, right? So really for BA, I could put this. Now watch this. Instead of putting BA, I can put BD plus DA, right? Because BA, this whole side here is really BD plus DA. And see this BC right here? Here's BC right here, right? Well, that whole side BC is really BE plus EC. So I can put BE plus BC, okay? And of course, it would be BE up top here. Now students, please pay really close attention to this. Do you notice up here how BD equals BA? BA equals BC, correct? There's an equal sign here. So if the two fractions are equal, that means this top here has to equal this here, okay? So if that's true, then look at this. What am I adding here to DA? BD, correct? Sure. What am I adding to BC? Now watch this, guys, watch. This is really good, strong reasoning skills, and that's where years ago they got these theorems, okay? So watch this. What am I adding to BC here? BE. What am I adding to DA? BD. What do we know about BD and BE? They're equal. So really, there is absolutely no reason why, if these two fractions are equal, which they are, there is no reason why you cannot take this away and this away from the bottoms of the fraction, because they're equal. It's like taking 3 away from both of the denominators, and the denominators are already equal, okay? So, with that in mind, if I take away this and this, I'm left with BD over what? DA equals BE over BC. Now students, we're almost done. Look what I have. I have BD over DA. Let's go back here. BD over DA. BE over BC. BE over, EC. I'm so close. Okay, but hold it. let's come back over here. We learned this already, that when you have two ratios like a proportion, you can swap your means or your extremes, okay? So really, what I want to get right here is an EC, okay? I want to have an EC right here for my BC. So remember, whenever you have a proportion, you can swap these two, and it still remains a true statement. We talked about that. So BC goes here, and BD goes here. So now look, BC has to equal BE. So for BC right here, I can definitely put, I think I did that backwards. Hold on 1 second here, guys. Sorry. Hold on just 1 second. Okay, students, I'm really sorry, and thankfully I'm not making you take, do a proof of this. I'm just trying to show it to you. When I put BE over BC, do you see this BC right here? I said BC equals BE plus EC. This should have been an EC right here, I'm sorry. So when you cross this off, you really were left with EC. So you were done right there. So there we go. If you'll look, let me grab this and pull this over. This right here. Totally matches this proportion here. BD, BD, DA, AD, BE, BE, EC, EC. So we're good. We've done it. I mean, we have taken, I know it wasn't pretty, and I don't expect you to get up in front of the class and teach that, but that is a good, solid explanation of where that theorem came from. Okay? Alright, now let's continue on. Let's apply this to a problem now, okay? So please take some really good notes on this. Copy this in your notes. I want you to solve for x. I'll give you just a second to copy this in your notes. And then I want us to solve for x. Quickly copy this in your notes, and then we'll solve for x. Anytime we do a problem like this, please feel free to work ahead. I have no problem with that at all, as long as you keep one eye up here and make sure you're doing it correctly and listen to what I'm saying. Alright, here we go. Okay, now notice we have a triangle, and in that triangle we have a side drawn inside of it, parallel to the third side. So we know that we can state 5 over 2 equals 6 over x. Or you could also say 5 over 6 equals 2 over x. Either way you'll get the same answer, okay? 5 times x is 5x. 2 times 6 is 12. Divide both sides by 5, and x equals 2 and 2/5, or 2.4, okay? Same thing here, 5 times x is 5x. 2 times 6 is 12. Divide both sides by 5, and you would get 2 and 2/5, or 2.4, okay? So there we go. Anytime you have a triangle with a side, with a segment drawn inside the triangle that connects two sides and is parallel to the third side, then it divides these sides up here and these sides up here proportionally. Okay, now let's continue on. The next theorem is the converse of the last theorem. So now we're going to say this. If these two sides are divided up proportionally, then these two lines here are what? Parallel. Okay, so now we're going to look at the converse. Please copy this down. You're responsible for this theorem on upcoming tests and quizzes, okay? And here it is. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. There it is. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. I'm going to wait a second while you copy that down. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. If you're not done copying that down, continue to work on it. I want to give you something to write down here, okay? Alright, here's a triangle. Please copy that in your notes. Then we'll put a line here, okay? And we're going to call this A, B, C, D, E. Now here's what I'm going to put. Please take some really good notes, students. If, Now remember, if this line right here divides these two sides up proportionally, so if AB over BC equals AE over ED, or there's another way you could write it, AB over AE equals this segment here over this segment here, BC over ED. If that happens, then what do we know? We know that BE is parallel to CD. Okay, I'm going to pause a second and come up for oxygen and take a breath. I want you guys to go ahead and finalize your notes here. Then we're going to continue on. So that's what this theorem is saying. Okay, now we're going backwards. If a line is drawn so that these sides here are proportional to these over here, then these two lines right here are definitely parallel. Okay, I'm going to move on. If I'm going too fast, just pause the video. Now, I won't go into an explanation of this theorem except to say the following. You would just go backwards, guys. You would start off by saying, hold on, give your old teacher a second here. You would just start off by saying, okay, I have proportional sides, so write it like this. Then make some substitutions, and then put these sides in here. And then after you state this and this, you could then state that you have similar triangles. Once you state that you have similar triangles, you could then state this angle is congruent to this angle, and this angle is congruent to this angle. And then once you state that, and you come up here, you know these two lines have to be parallel, because corresponding angles are congruent at any time two lines are cut by a transversal, so the corresponding angles are congruent, then the two lines are parallel. I do not expect you to know what I just said, and some of you understood it, and some of you did not, but I'm just trying to show you, you would just go backwards if you were to do a proof of Theorem 8.5, okay? Alright, now, moving on, let's go ahead and take a look at a problem here, and see if we can work a problem out. So take a second, please, and copy this problem in your notes if you would, okay? Copy that down, and then we'll go ahead and work it out together. If you want to work ahead, please feel free to do that, okay? Copy this down. A, B, C, D, E, 8 here, 3 here, 6 here, and a 4 here. My question is this line here parallel to this line here? You can work ahead or you can wait for me. Okay, we just had a theorem that said if this side here is divided up proportionally with this side over here, then the line's parallel. So students, here's what we're going to do. We're going to take this segment here, put it over this segment here. That'll be 8 over 3 equals, now we're going to take this segment here over this segment here, 6 over 4, okay? Now remember, there's another way to set up your ratio too. You could say 8 over 6 if you wanted to equals 3 over 4, and that would be fine also. But here's what you're going to see, students. You're going to see no matter what, you do not get two true statements. It doesn't work, okay? 8 over 3 cannot be reduced, and 6 over 4 can be reduced to 3 halves. Are these two fractions equal? Obviously no. The same thing's going to happen over here. 8 over 6 reduces to 4 thirds. 3 fourths cannot be reduced. Is 4 thirds equal to 3 fourths? Well, the answer is no. Students, no matter what, this line here does not divide this side up and this side up into proportional parts. So even though this line looks parallel, it's not. This line here is not parallel to this line here because we did not have this side divided up proportionally to this side over here. Okay? Alright, let's continue on. Now, let's shift gears and let's look at two theorems that do not deal with triangles, okay? So here's the first theorem. Copy this down, you're responsible for it. Theorem 8.6. If 3 parallel lines intersect transversals, then they divide the transversals proportionally. Okay? If three parallel lines intersect two transversals, then they divide the transversals proportionally. I'll give you a couple more seconds to copy that down, then we're going to move on. Okay, here we go, students. Three parallel lines. That's not very parallel, is it? 1, 2, 3. Transversal. Transversal. Alright, now please watch carefully, students. I'm going to say this line here is parallel to this line here, parallel to this line here. I'm going to call this point A, B. Please copy this down in your notes, students. C, D. If I'm going too fast, just let the teacher know. E, F. Now, we're going to call this, we'll say this, F. Lines AD, BE, and CF are what? Parallel. Then here we go, students. I could say AB over BC equals this segment over this segment, DE over EF. Or I could say this segment over this segment, AB over DE equals BC over EF. Okay, so there it is. Take a second to finalize your notes. I'll be going on in just a minute. If I'm going too fast, just have the teacher pause the video. But if I have three parallel lines cut by two transversals, then this proportion or this proportion is correct. Okay, alright, now you're going to prove this theorem in problem number 28 in the homework section of this lesson later, okay? So contain your excitement there. Now, let's go ahead and work on a problem. Let's take a minute, students, and turn your books to page 407. So go ahead and do that, please. Let's take a look at example number 2, drawn in your book for you. I'm going to go ahead and try to draw it while you're turning in your book. You'll see it looks like this. And then this. And then this. And then this here, okay? Now, it looks like we have, they want us to find the length of TU. So I'm going to go ahead and label these real quick. Actually, I'm not going to take time and put the letters on here. I'm just going to tell you now, they're calling this angle 1. It looks like this angle 2 and this angle 3 down here, okay? And they want us to find the length of this right here. I'm going to put an X right here, and they tell us the length of ST is 11, so this length here is 11, and let's see, PQ is 9, so this length here is 9, as you can see in your book, and then QR is 15. Now, they don't tell us that these three lines are parallel. Do you understand that? What they do tell us is this. They tell us that angle 1 is congruent to angle 2, which is congruent to angle 3. Now guys, come on, we should recognize this right away. Look, if two lines are cut by a transversal in such a way that their corresponding angles are congruent, those two lines are parallel. So I know for sure these two lines here are parallel. Then let's look at it like this. Here's two lines cut by a transversal in such a way that their corresponding angles are congruent. Well, anytime two lines are cut by a transversal in such a way that their corresponding angles are congruent, those two lines are parallel. So this line here is parallel to this line here. Okay, I really had to establish that first before we went any further. There we go. So now look what I have, students. I have three parallel lines cut by two transversals. So these two transversals are cut up or divided proportionally. So I can say 9 over 15 equals 11 over x. Or I can say 9 over 11 equals 15 over x. Either way, you'll get the same answer, okay? Over here, I can reduce this fraction to make it a little easier. 3 goes into both those numbers. So I get 55, 5 times 11 equals 3x. So my answer would be, let's see, 18 and 1/3, or 18.3, okay? Alright, now let's come over here. 9 times x is 9x, and 15 times 11 would be 165. Divide both sides by 9, and you're going to get, let's see, 75, that's 8, 72, and 3/9. So I'm getting 18 and 3/9, which reduces to 18 and 1/3, or 18.3, repeating. So it doesn't matter which proportion you use, you'll get the same answer. Okay? So if three parallel lines are cut, or intersect two transversals, then they divide the transversals proportionally. Alright, moving on to our fourth theorem of the day. Here it is. Please copy this in your notes. Theorem 8.7. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Pretty interesting, okay? So, if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Now, I did make a mistake up here. I said, let's look at two theorems that do not deal with triangles. I should have said, let's take a look at one theorem that does not deal with a triangle, because this last theorem does deal with a triangle, so I apologize for that mistake. But anyways, if a ray bisects an angle, it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So let's get a picture of this. Here's my triangle. Actually, I might have a picture of it here. No, I do not. Okay, so here's my triangle. Alright. And we're going to draw a line right here. Please write this in your notes, students. And we're going to go ahead and put a congruent mark here and a congruent mark here, okay? We're going to call this A, B, C, D, okay? Now, here's what we got. If BD, now I'm going to do this differently. I'm going to call this angle 1 and angle 2. Okay, students, if angle 1 is congruent to angle 2, that's all I gotta put. Now think about that for a second, students. If angle 1 is congruent to angle 2, then I know that BD is what? An angle bisector, and that's what the theorem says. If a ray bisects an angle of a triangle, so I'm just gonna put if 1 is congruent to 2, then we know we have proportional sides, so I can say then AD, and watch carefully, AD over AB equals DC over BC, okay? Or I can say, let's look at it again, I can say AD over AB equals DC over BC. That's totally fine. Or you could say this, you could say AD over DC, AD over DC equals AB over BC. Okay, so there we go. Let that sink in. I'm going to move on to another page like this. So if I'm going too fast, pause the video, but this should make total sense. If angle 1 is congruent to angle 2, then we have these proportions right here. Okay, alright, let's continue on. This theorem will be proven in number 29 in the homework section of this lesson. Okay, alright, now This is a pretty simple problem. I don't think it's too difficult, okay? Notice I have a triangle, so go ahead and draw your triangle. I have a line drawn right here in such a way that this angle here, right here, is congruent to this angle here. We'll call it angle 1 and angle 2, okay? I'm going to grab a drink here. Go ahead and copy that in your notes, please. Okay, here we go. Now, first of all, students, I have a triangle right here. Notice that, okay? So I've got a triangle. Secondly, I have a line drawn from this vertex here that divides this angle up into two congruent angles. So that means this line here, this ray, this line is an angle bisector. It is, okay? So if that's the case, then I definitely have some proportions here. I can say 7 over 12 equals 6 over x, or I can say 7 over 6 equals 12 over x. Either way, we'll get the right answer, okay? 7x equals 72. Divide both sides by 7, and we will get 10 and 2 sevenths. Not sure what the decimal would be, okay? 6 times 12 is 72. 7 times x is 7x. Divide by 7, and you will get 10 and 2 sevenths equals x. So it does not matter which proportion you choose to use, okay? Guys, students, I hope that this video has been a help to you. If you have any questions, don't hesitate to call or email.